Assalamualaikum and a very good evening to our esteemed lecturer, Sir Zulikian, and to our fellow students. First and foremost, we would like to express our sincere gratitude for this opportunity to share our knowledge and findings with all of you. It is truly an honor to stand before you today and present our topic, which is polymer manufacturing process. Before we proceed, please allow us to introduce ourselves so that you may get to know the team behind this presentation.
Assalamualaikum. My name is Awangku Emru Muminin bin Awangku Gaide. My student ID is 2024664284.
I am Mukrisha bin Ayatullah and my student ID is 2024665644.
My name is Nuranya Ilham binti Abdul Ahmid and my student ID 2024631238.
My name is Shaza Hazira binti Shifrizal and my student ID is 2024245298. What are polymers? Polymers are large molecules made up of repeating smaller units called monomers. These units are chemically bonded in long chains. The term polymer originates from Greek, where poly means many and mer means part.
There are three main types of polymers: natural, semi-synthetic, and synthetic polymers. Natural polymers are found directly in nature. Examples include cellulose, starch, proteins, DNA, and natural rubber. These are used in things like paper, food products, fabrics, and biological materials.
Secondly, semi-synthetic polymers. Semi-synthetic polymers are chemically modified natural polymers. There are many examples of semi-synthetic polymers such as cellulose acetate and nitrocellulose. These semi-synthetic polymers are used in photographic films and coating.
Lastly, synthetic polymers are completely man-made through chemical processes. These include materials like polyethylene, PVC, nylon, and polystyrene. They are widely used in packaging, clothing, and electronics. Each type has its own role depending on its source and application.
Few stage in polymer manufacturing. One of them are raw material preparation, polymerization, additional polymerization, polymer processing technique, post-processing and finishing of polymers, and application of polymer.
Let's explore the raw materials used in polymer production. Monomers such as glucose, fructose, and galactose are primary raw materials. Catalysts like benzoyl peroxide and Ziegler-Natta catalysts are used to speed up polymerization. Initiators like free radicals start the process, and the reaction can be controlled for desired outcomes.
To give polymers desired characteristics, additives are introduced. These include plasticizers for flexibility, stabilizers to prevent degradation, fillers to increase strength, and colorants for appearance. In some processes, solvents are also used to help with mixing and reaction control. As sustainability becomes more important, manufacturers are also exploring renewable feedstocks, for example, using sugarcane instead of crude oil to make polyethylene.
What is polymerization? It is a chemical reaction where monomers link together to form polymer chain. It involves breaking and reforming of chemical bond. There are two main types of polymerization. First is addition and second is condensation. In addition, polymerization monomers add one by one to a growing chain. It is initiated by free radicals, cations, or anions and produces no byproduct. For example, include polyethylene, polypropylene, and polystyrene. Condensation polymerization involves monomers with two functional groups react step by step, forming byproducts like water or HCl. Examples of polymers formed this way are nylon, polyester, and polycarbonate.
Addition polymerization starts with reactive species like free radicals that attack monomers, creating active sites. These sites rapidly add more monomers, forming long chains. The process ends when an active chains combines or deactivate, resulting in polymers like polyethylene or polystyrene.
Addition polymerization is a fast and efficient method used to make many common plastics. This process uses monomers that contain double bonds like ethylene, which open up and link together to form long chains.
This process consists of three main steps, which is initiation, propagation, and termination. In the initiation step, a free radical, cation, or anion is generated by a chemical initiator. The reactive species attacks a monomer and starts the chain reaction. Next is propagation, where is the active polymer chain continues to add more monomers. The chain grows rapidly. Finally, termination occurs. Chain growth stopped by combination or disproportionation. The final polymer is stable.
Polymer processing involves several techniques. Extrusion force molten polymer through a shaped die to create continuous forms like pipes and sheets. Injection molding melts and injects polymer into mold cavity for complex shapes. Blow molding inflates heated plastic inside a mold to form hollow objects such as bottles.
Compression molding, on the other hand, is mainly used for thermoset plastics. It compresses polymer in a mold, often for durable parts like electrical components. Finally, fiber spinning is used to make synthetic fibers for clothing and industrial applications. Polymers like nylon or polyester are melted and drawn into long threads. Each method is chosen based on the polymer's behavior and the desired product.
Polymers undergo post-processing and finishing of polymers. What is post-processing? Post-processing involves all steps after shaping to improve the functionality, durability, and appearance of polymer products before commercial use.
After shaping, polymers undergo post-processing steps. Cooling and solidifying are crucial to maintain shape and prevent warping. Cutting and granulation trim large parts, remove excess material, and prepare recycled polymers. These steps ensure polymers are ready for reuse and further use.
Surface finishing is done to improve the look and feel of products. For example, coatings may be added for gloss or even metallic effects. Finally, every product undergoes quality control testing to make sure it meets the required specification. Only then is it ready to be packaged and distributed.
Polymers are incredibly versatile and widely used material. Why are polymers so widely used? Their widespread use is due to several key characteristics. They are lightweight, durable, moldable into various shapes, cost-effective, and resistant to chemical and corrosion.
Polymers have diverse applications across industries. In packaging, they are used for bottles, bags, and food containers. In construction, they form pipes, insulation, and seals. The automotive industry employs polymers for bumpers, dashboards, and fuel tanks thanks to their durability and lightweight properties.
In textiles, synthetic fibers like nylon and polyester make up clothing, carpets, and industrial fabrics. They are durable and resistant to wrinkle and moisture. In medicine, polymers are critical. Disposable items like syringe, gloves, and IV bags must be sterile, safe, and cheap. So medical-grade polymers like PVC and silicone are used. Lastly, in electronics, polymers help insulate wires, protect devices, and form circuit boards.
In conclusion, polymers are important materials used in many industries. Their production involves several steps, from raw materials to polymerization, processing, and finishing. As technology improves, polymer manufacturing is becoming more efficient and environmentally friendly.